Thin-layer chromatography. Stationary phase. The stationary phase is a relatively thin, uniform layer of dry, finely powdered material applied to a glass, plastic, or metal sheet or plate, typically called the plate. The stationary phase of thin-layer chromatography, TLC, plates has an average particle size of 10 to 15 micrometers, and that of high-performance TLC, HPTLC, plates has an average particle size of 5 micrometers. Commercial plates with a pre-adsorbent zone can be used if they are specified in a monograph. Sample applied to the pre-adsorbent region develops into sharp, narrow bands at the pre-adsorbent-sorbent interface. The separations achieved may be based on adsorption, partition, or a combination of both effects, depending on the particular type of stationary phase. Thin-layer chromatography. Stationary phase. Apparatus. A chromatographic chamber made of inert, transparent material and having the following specifications is used: a flat bottom or twin trough, a tightly fitted lid, and a size suitable for the plates. The chamber is lined on at least one wall with filter paper. Sufficient mobile phase or developing solvent is added to the chamber so that, after impregnation of the filter paper, a depth appropriate to the dimensions of the plate used is available. The chromatographic chamber is closed and allowed to equilibrate. Note: unless otherwise indicated, the chromatographic separations are performed in a saturated chamber. Detection/visualization. An ultraviolet, UV, light source suitable for observations under short, 254 nanometers, and long, 365 nanometers, wavelength UV light and a variety of spray reagents to make spots visible are often used. Spotting. Solutions are spotted on the surface of the stationary phase plate at the prescribed volume in sufficiently small portions to obtain circular spots of 2 to 5 mm in diameter, 1 to 2 mm on HPTLC plates, or bands of 10 to 20 mm times 1 to 2 mm, 5 to 10 mm times 0.51 mm on HPTLC plates, at an appropriate distance from the lower edge and sides of the plate. Note: during development, the application position must be at least 5 mm, TLC, or 3 mm, HPTLC, above the level of the mobile phase. The solutions are applied on a line parallel to the lower edge of the plate with an interval of at least 10 mm, 5 mm on HPTLC plates, between the centers of spots, or 4 mm, 2 mm on HPTLC plates, between the edges of bands, then allowed to dry. Procedure. 1. Place the plate in the chamber, ensuring that the spots or bands are above the surface of the mobile phase. 2. Close the chamber. 3. Allow the mobile phase to ascend the plate until the solvent front has traveled 3/4 of the length of the plate, or the distance prescribed in the monograph. 4. Remove the plate, mark the solvent front with a pencil, and allow to dry. 5. Visualize the chromatograms as prescribed. 6. Determine the chromatographic retardation factor, RF, values for the principal spots or zones. 7. Presumptive identification can be made by observation of spots or zones of identical RF value and about equal magnitude obtained, respectively, with an unknown and a standard chromatographed on the same plate. A visual comparison of the size or intensity of the spots or zones may serve for semi-quantitative estimation. Quantitative measurements are possible by means of densitometry, absorbance or fluorescence measurements.